Dear students, in this lecture, I am going to introduce to you the basic concepts of jigs and fixtures. Jigs and fixtures are very important production devices. They play a very vital role in improving the manufacturing efficiency and as well as the productivity of a company. So this is what the basic outline of my lecture is going to be. We will be covering the objectives of tool design. So what is meant by a jig? What are the types of jigs? So what do you mean by a fixture and the types of fixtures? What's the basic difference between a fixture and a jig? What are the principles of fixture and jigs design, and so on. Functions and advantages of jigs and fixtures. So what is tool design? So if we say the tool design, the basic definition is it is a critical aspect of manufacturing and production processes. The objectives of tool design are to create efficient, reliable, cost-effective tools that help streamline manufacturing processes. And not only that, the specific objectives of tool design, if you see, it includes product quality, which makes sure that the tools are designed to produce products with the desired quality and precision, meeting the specified tolerances and standards. The other part is the efficiency. Of course, we all know the design tools that optimize production processes, reduce cycle times, and maximize the productivity. And efficiency also can lead to cost savings and higher output. So what about the cost factor, the cost reduction? So strive to minimize tooling costs by selecting materials and designs that are cost effective without compromising quality or performance. Now coming to the reliability and durability, with the tool design helps us to create tools that are robust and capable of withstanding the stresses and wear and tear of continuous use. Not only that, this also reduces the downtime and maintenance costs. So that is something that we usually read in the lean manufacturing part. Right? What about the safety? Of course, prioritize the safety of operators and workers by designing tools and safety features and considering ergonomics and also the ease of use. Now, the other important thing is the precision accuracy, which ensures make sure that the tools are capable of producing components with the required precision and accuracy to avoid rework and scrap, which is a very big problem for the manufacturer. The seventh one is the versatility, where they design the tools that is multiple tasks. Different products where applicable can be done to maximize the utility. What about the material selection? So material selection, if you see, chooses the right type of material for the tools based on the factors such as strength, heat resistance, and wear resistance. The ninth one is the ease of maintenance. Of course, they design tools that are easy to maintain and repair, reducing downtime and the maintenance costs. Now coming to the 10th one is the environmental consideration. These days we are talking about the environmental sustainability, right? So consider the environmental impact of the tool production and operation, striving for sustainability and also minimizing the waste, which is the concept of MUDA, right? Minimizing the waste. Now coming to the standardization, of course, standardized tool designs and components wherever possible to simplify maintenance, reduce the costs, ensure interchangeability, which is a very important characteristic of manufacturing, the arena. Now coming to innovation, embrace new technologies, innovative design, right? Approaches to competitive and improve the manufacturing processes. What about the documentation part? Of course, the properly document the tool designs, including the drawings and specifications to facilitate manufacturing and maintenance, and of course the quality control part of it. What about the cost benefit analysis? So evaluate the cost of the tool design, production against the anticipated benefits in terms of increased efficiency, even the reduced production costs, and as well as the improved product quality. The 15th one is the compliance. So you have to ensure that the tool designs adhere to the relevant industry standards, regulations, and as well as the safety guidelines. Now, what about the longevity? Of course, we have the aim for the tools should have a longer life, in order to avoid frequent replacements. And the customization, so whenever it is necessary, design the tools that are tailored to specific production requirements, so ensuring that they meet the unique the needs of the operation. And the 18th one is the training part. So training means, of course, considerable amount of training and skill level of operators is necessary to ensure that the tools are designed with user friendliness in mind. So by focusing on all these objectives, the tool designers can contribute to more effective and manufacturing processes, leading to improved product quality and reduced production costs. So what is a jig? Right? So what is basically a jig? A jig basically is a mechanical device or a tool used in manufacturing, machining and other industrial processes to assist in guiding, holding or even positioning a workpiece or tool or machine component. So we can say locating, holding and supporting the workpiece. These jigs are also designed to ensure precision, consistency and repeatability in various manufacturing operations. So they are particularly common in processes such as say drilling, say milling, welding, assembly, right? So we will see some key aspects, okay, some key features of and even the purposes of the jigs. So guiding and holding, a very, very important characteristic of a good jig. So jigs are designed to securely hold and guide a workpiece and even the tool also in a specific position during the manufacturing. That is the one that demarcates a jig with a fixture. So a fixture only locates, holds and supports the workpiece, whereas a jig is also used to locate, hold, support and as well as guide the cutting tool. Right. The second most important thing is the precision. So jigs are built to exacting say specifications to achieve high levels of precision and accuracy in the machining or the assembly of parts. So this precision is critical in industries where very close dimensional tolerances are very much required, right? What about the other concept called as repeatability? Of course, jigs are used to ensure that the same operation can be performed repeatedly with consistent results. So this is particularly important in the case of say mass production, right? What about the safety part? Of course, jigs can always improve the safety by reducing the need for operators to handle or manipulate workpieces directly, minimizing the risk of the accidents and injuries that might happen. Of course, the productivity, yes. So jigs help streamline manufacturing process, reduce the setup times and also increase the efficiency of operations, which we already covered in the first slide itself. So ultimately leading to higher productivity. So what are the types of jigs? So when it comes to jigs, see drilling jigs they are used for guiding and positioning the drilling tools to create holes in workpieces with precise locations and as well as angles. Milling jigs designed for guiding milling cutters in milling machines to shape or profile workpieces accurately. Welding jigs, of course, it is used in the welding operation, assisting the aligning and holding the workpieces together during the welding operation to ensure proper joint configuration and the quality of the joint. Assembly jigs, as the name suggests, it helps in the assembly of the complex products, positioning and securing the components in the correct orientation. Inspection jigs, of course, we also have the inspection fixture. We also have the inspection jig. So it is used for quality control and inspection to verify that the workpieces or components meet the specified dimensions and close dimensional tolerances. We have the routing jigs or the routing jigs, guide routers in woodworking or other applications to cut shapes, patterns or designs in materials. We also have the grinding jigs, so that that is guide grinding wheels or abrasive tools for precision grinding operations. Template jigs, as the name suggests, templates are the patterns that serves as guides for various operations such as marking, cutting or drilling. And the template jigs means it is going to occupy the exact shape of the component. So that the marking, cutting or the drilling part can be done very easily. It is generally used for woodworking and the craft applications. What about the indexing jigs? The indexing jigs are used to rotate or position the workpieces at specific intervals or angles, allowing for the machining of features at precise locations. Boring jigs. So what is a boring operation? We enlarge the already existing hole. So boring jigs guide boring tools for enlarging or finishing the pre-existing holes accurately. Punching jigs, punching operation is carried out. So punchings guide the punches or the dies for creating holes, notches or shapes in sheet metal or other materials that are commonly used in sheet metal working operations. So how a jig differs from that of a fixture? So jigs and fixtures are both essential tools we already seen in manufacturing and machining. A jig is a tool that is going to locate, hold, support and guide the cutting tool. What about a fixture? A fixture doesn't do that. Fixture only locates, holds and supports the workpieces. Of course, there are some very distinct differences between them. For example, the way the workpiece is being held. The workpiece holding, if you see, the fixtures are primarily designed to hold and secure the workpiece in a specific position during the machining or the assembly. They do not guide the cutting tools, but are used to hold the workpiece in a very rigid manner. You see the versatility part. Fixtures are more versatile when compared to jigs and can be used for multiple machining operations or with different workpieces, as they primarily serve only to hold the workpiece in a very in a fixed position, right? What about the multi-purpose? See, fixtures are often designed to accommodate a range of workpieces of different shapes and sizes, making them adaptable to various production. Whatever the requirements that comes up. And the complexity part is, it is more, in terms of complexity, fixtures can be more complex than the jigs because they need to provide flexibility and adaptability for different workpieces and for the various manufacturing processes, right? Interchangeably, another important characteristics, where the fixtures are typically designed to be interchangeable, meaning that they can be used with various workpieces or adapted to different processes, enhancing their versatility. So examples, if you see, you have the inspection fixtures, assembly fixtures, milling fixtures and so on. So in summary, jigs primarily guides the cutting tool and the locates, holds and supports the workpiece, whereas a fixture only locates, holds and supports the workpiece alone. And what about these are some of the basic differences that we have seen between a jig and a fixture. Although both the jigs and fixtures are critical in manufacturing to ensure precision, consistency and efficiency in production. So fixtures, they form a very important integral part of manufacturing and machining processes used to hold and position the workpieces during the various operations. So there are several types of fixtures that we will be seeing in a moment, each designed for specific applications and manufacturing processes. So based on the type of operation that is being performed, we can call it as the milling fixture, where these fixtures are used in milling operations to hold the workpiece securely in a while the milling cutters shape or machine the workpiece. So milling fixtures are versatile and can be designed to accommodate various workpiece shapes. What about the welding fixture? So welding fixtures, again, it holds and position the components to be welded together, ensuring proper alignment and welding quality. So they are critical in industries, especially the automotive, shipbuilding and as well as the construction industries. And again, we have the assembly fixtures. As the name suggests, assembly fixtures are used in assembly process to secure and align components accurately, and they ensure that the products are assembled with the correct orientation and perfect fit. Inspection fixtures, of course, in the QC area. Inspection fixtures are used for quality control and inspection purposes, and they are designed to check the dimensions and tolerances of workpieces to ensure they meet the specified standards. The boring fixtures, of course, enlarge the existing hole, and it does the same thing where it is going to locate, hold and support the workpiece, where the internal features or the boards need to be machined with a very high amount of precision. The grinding fixtures, we have in the grinding fixture, a number of grinding fixtures are there. Again, while the grinding with abrasive tools are going to make the grinding operation, this proper shaping is going to happen. We have the sawing fixtures, where it is used for the sawing operations to ensure straight and accurate cuts in materials like metal, wood or plastics. And then again, the punching fixtures, where it guides the punches and dies to create holes, notches and other shapes in materials. Indexing, similar to the indexing jigs, we have the indexing fixtures, where there is the rotator position the workpiece at specific angles or intervals. And I am sure that you might have done it in the while manufacturing the gear, the indexing operation. The same thing, indexing fixture, you can just correlate that operation with that of the indexing fixture. We have the hydraulic and pneumatic fixtures, and where these fixtures are designed to hold and manipulate hydraulic or pneumatic components, ensuring proper alignment and connection in hydraulic or the pneumatic systems. Then we have the tooling fixtures. So as the name suggests, tooling fixtures are used to secure and organize the tools in a specific configuration, often found in tool and die shops and machine tool setups. Casting and molding fixtures. So you can just see all these names are associated with the type of operation that is being carried out. And what about the metrology fixtures? The metrology fixture, if you see, Again, this is used for precise measurement and even for calibration of the existing equipment, ensuring that the measurements are accurate and even repeatable. And you have the flexible and the modular fixtures. That is the one of the latest type of fixture is the modular fixture, where these fixtures are designed to be adaptable and can be reconfigured to accommodate various shapes, and there is workpiece of various shapes and processes, and they offer flexibility in manufacturing setups. So these are just some of the many types of fixtures used in manufacturing and assembly processes. So the choice of fixture type depends on the specific manufacturing operation, the workpiece characteristics, and the desired level of precision and the efficiency that is being targeted. Now we will talk about what are the principles of jigs and fixture design. Again, it's a very important aspect of designing of a jig and a fixture. So designing effective jigs and fixtures is crucial for improving the manufacturing efficiency and also for ensuring the product quality. So what are the key principles that we need to consider while designing a jig and a fixture? The precision and accuracy. Of course, jigs and fixtures should be designed to achieve the required level of precision and accuracy. This includes accurate positioning of the workpieces and tools to meet specified tolerances. And the second most important thing is the interchangeability, which we already we saw in the previous slide. So whenever possible, the design jigs and fixtures to be interchangeable so that they can be used with the different workpieces or even the case of even for various processes. So this reduces the need for custom designs and saves the time and cost. Standardization, of course, the standardize the components and design features to minimize complexity and facilitate maintenance. Common components, if you see, can also be more readily available, say cost effective. Now coming to simplicity part, keep the design as simple as possible. Complexity can lead to increased cost, longer setup times, and more opportunities for errors. What about the ergonomics part? So consider the ergonomics of the setup, making it easy for operators to load and unload workpieces and operate the machinery safely and efficiently. Now coming to the stability and rigidity, ensure that the jigs and fixtures are stable and rigid to withstand forces and vibrations during the manufacturing processes, reducing the risk of deflection or deformation. Material selection, of course, you have to choose the right type of material that are durable, resistant to wear, and suitable for the environment in which they will be generally used. Accessibility, design the jig or the fixture so that all parts are easily accessible for quick maintenance, adjustment, and cleaning. The safety, so you have to prioritize the safety by incorporating safety features such as guards, safety interlocks to protect the operators from potential hazards. What about the optimized workflow? So ensure that the workflow from loading the workpiece to completing the operation is smooth and efficient, minimizing unnecessary movements and handling. Cost efficiency, of course, balance the cost considerations with the need for precision and functionality. Consider the cost of materials, manufacturing and maintenance while designing the jig and fixture. Documentation, in this case, properly document the design, including the detailed drawings, specifications to ensure consistent manufacturing maintenance and quality control. What about the testing and validation? So thoroughly test and validate the jig or the fixture design to ensure that it meets the required specifications and performance standards. Flexibility, so when applicable, design jigs and fixtures to accommodate various workpiece sizes and shapes. This flexibility can improve the versatility of the tooling. Modularity, so modular designs allow for easy adjustments and reconfiguration, which can be particularly useful in scenarios where product designs change frequently. Provision for adjustability, incorporate features that allow for easy adjustment of critical dimensions, especially in situations where workpieces may have slight variations. Tolerance stack-up. Consider the tolerance stack-up effects and design the jigs and fixtures to accommodate the potential vibrations in workpiece dimensions. Material handling, include features for efficient and safe material handling such as lifting points or channels for conveyors. So by adhering to these design principles, designers can create jigs and fixtures that enhance manufacturing processes by improving accuracy, repeatability, and efficiency, while also ensuring safety and cost effectiveness. Thus, we have seen jigs and fixtures play a crucial role in manufacturing and machining processes, offering a range of functions and advantages to improve efficiency and quality. Here are the primary functions and advantages of jigs and fixtures. The workpiece positioning, that is very, very important. So jigs and fixtures securely hold and position the workpiece in the desired orientation for machining, assembly or inspection. Tool guidance, jigs guide cutting tools such as drills or milling cutters to follow a specific path or trajectory to achieve precise and accurate machining. Repeatability, jigs and fixtures ensure that the same operation can be performed consistently, repeatedly, reducing the errors. Now coming to the other most important part is maintaining high precision and quality standards. So how do you achieve this? So the jigs and fixture, they help to maintain tight tolerances, close dimension tolerances, ensuring that the components or parts are manufactured with very high precision, meeting quality standards. The coming to the safety part, which we have seen, right? The operator safety is of really very, very important. Right, so I have to design in such a way that the operators are not injured or something like that. Okay? So what about the efficiency part? So streamline the efficiency, minimizing the operator intervention, so improving the workflow, ultimately leading to the very high productivity. And coming to the versatility part, fixtures in particular can be designed to accommodate various workpiece shapes and sizes, making them versatile for different production needs. The quality control part, inspection fixtures are used to verify that workpieces meet specified dimensions and tolerances, contributing to quality control. And the cost reduction, jigs and fixtures can reduce scrap, rework and tool wear, resulting in cost savings and increased profitability. So these are some of the advantages of jigs and fixtures. Precision, which we already seen. Jigs and fixtures help achieve a very high precision manufacturing process, ensuring the components are produced with very high accuracy. Consistency, they provide the consistent results across multiple workpieces or batches, reducing variations in product quality. And timing savings, if you see, the setup times are minimized with the use of jigs and fixtures, leading to shorter production cycles and increased efficiency. What about the labor savings? They reduce the need for skilled operators to perform tasks manually, potentially lowering the labor costs. Now, improved product quality, the accuracy and consistency product of the jigs and fixtures lead to higher product quality and fewer defects. What about the reduced waste? So less scrap and rework result in reduced material waste and cost savings. I think the safety part we have already seen. Operator safety is of the essence, where the operators can work without facing any kind of an injury. The fixtures in particular can be adapted for different workpiece or the processes, reduce the need for specialized tooling. And the jigs and fixtures can also be standardized, making them readily available and ensuring consistent quality across multiple manufacturing sites. Increased productivity, which is the ultimate goal. By optimizing the machining and assembly processes, jigs contribute for an increase in productivity. So jigs and fixtures, they form a very, very important the dimension as far as the production process is concerned, right? So in this video, dear students, we have seen the objectives of tool design. So what is meant by a jig? What are the types of jigs? What are the types of fixtures, right? So functions and advantages of jigs and fixtures. And I hope this video was quite informative to you guys. Thank you for listening. Appreciate your time. Thank you.